Well, hi, good morning. Thanks so much for joining me here in my shop for another shot at this radio. I'm going to spend a little bit of time reasoning through where I'm at and what I'm going to try to do next. I've got obviously to do something different. Yesterday I came in my shop, worked away at trying to realign the radio, thinking that the problem with the radio, by the way, is no stereo. It will not flip into stereo. The stereo light will not come on. I can force it on if I use my signal generator back here and just turn the levels up high enough, the light will come on and the set will operate in stereo. So that suggests to me there's nothing really wrong with the radio in terms of stereo. It's just not getting enough signal through from the antenna. I have repeatedly aligned this radio. I have tried various combinations of my test equipment to get the very best and most reliable response curves on my screen there. I have worked hard yesterday to get some frequency markers onto it, and no matter what I did, I could not achieve any higher level of IF output while having a broad bandwidth in the IF. So the instructions here have a curious thing in them, and that is this line here. For tuning the IF, it says cores to be adjusted away from each other. So yesterday at one point I decided, okay, I'll screw the cores close together in the two transformers, and then I'll align the set by drawing the cores back. Okay, so after doing that, the set is no longer aligned worth anything now. it went right out of control. And I was frustrated and kind of worn out anyway. Even notice I did not post a video on that because the end result was, really I got nowhere whatsoever with it. In fact, I went backwards with it. So now it's time to think hard about this. Why could that be? That no matter what I do to the IF, I never ever get what I need out of this radio. So one possibility is defective components somewhere in the radio, maybe in the IF. That's one possibility. Another possibility is I just really haven't done it right. The instructions here suggest that you just kind of randomly go at these cores in the two IF transformers. It doesn't really say it says right on it, in any order. That's a little odd. One of the options I have here is to try to examine each IF stage one at a time. So kind of feed a signal into the stage and look at what's coming out of that stage, not the whole thing, just stage by stage. That might help. What I might find out there is one of the stages is coming up short, and it doesn't matter what I do, I'll never get enough signal through it. Another thing that I've done here, I chose to not do some alignment activities. So these ones fall down here after the IF, and these are inside the FM tuner. They specify to do this at 108 megahertz. This presented me with a problem early on. That's what prompted me to try to get this sweep generator going. This one it's actually a much better generator for FM radios, is stuck on 100 megahertz. So I never performed any of this. But this is after the fact here. Could this be part of the picture? Well, it certainly could be. Some of these, so CO, CA, and CR, you have to look at what those mean, but one of them, CO, could be capacitor for the oscillator, capacitor for the antenna, and CR, capacitor, I don't know, it's a capital R there, I don't know what that is. Well, so I didn't touch any of these at all. I'm pretty gun shy fiddling around with the insides of an FM tuner box. But that could simply be the problem. If I just took the time to try to tune these, especially that capacitor antenna adjustment, and maybe I find out there's a whole pile of signal just not getting past even here. So even though I may have got this just beautiful, this guy may be eating all the energy up. So another thing I could do here is I could just say, oh, enough for the FM right now. Let's align the AM part of this. That should be straightforward. Yeah, it should be straightforward, and they really should be unrelated to the FM side of things. So, you know, I think maybe when my brain is really on fire, I'll use an AM alignment to kind of cool it off, but I'm not ready for that right now. So I'm just leaving that aside. The AM radio, you know, it's just not that important these days. Especially with a big radio that's going to be fixed in place, sitting in one place, antenna aimed one way. And what is there to listen to on AM radio anyway, here in Canada? And probably North America and maybe around the world too. It's just not an awful lot there. FM is what we really want, especially coming out of this is, you know, this is going into that fancy console I showed you the picture of. I hope I showed you the picture of that. Hey, maybe I didn't, because I'm doing things here and not posting, so I'm going to stop right now and flip that picture onto the video here. Okay, so this is just in case I didn't show this on an earlier video, because as I say, I'm not posting. Some days I'm not posting what I'm doing here. So anyway, this is what this stereo looks like. This is a wild looking thing. It's a real mod look to it. Check out those speakers there. Fantastic. So that's the receiver I'm working on right now, and this record player is just sitting in another room, waiting to come in here for a final check once I get this guy done. So that's a really wonderful looking thing, a real piece of Art Deco history, I would say. Well worth having, especially if it works well, especially if the FM radio works well, because you can listen to an FM radio all day long. So that's why I'm under such pressure to make this thing work. So I think what I'm going to do is I'm going to just take a little break here and ponder my next move, since I have a number of options here. I have to decide which one is the smartest one to do. I'm thinking testing out the tuning is maybe where I should go. I'm going to go think about it. Okay, I think I got a plan. So I think the first thing I'm going to do is tune the IF on a single frequency, 10.7, peak it up, pretend it's an AM radio, and get that part aligned with maybe improper bandwidth, but at least lined up on 10.7. With that in place, I can then monitor the output of the IF. I can fiddle around with the tuner adjustments, the antenna capacitor, and stuff like that. I don't dare do that with the IF out of alignment. Once I determine if the tuner is weak, the tuner tuning is weak, if I discover that, maybe what will happen is I'll bring up the strength of the radio just by fixing the tuner that I've ignored so far. Then I can start dealing with the bandwidth difficulties that I'm having in the IF. Perhaps all that work I've done is just never going to work out because there just isn't enough signal coming in the front door of the IF from the tuner. That's my plan. My guess is I'll get 5 minutes into this and the whole thing will go for a shit, basically. that's par for the course with this radio. So I'm going to get myself set up for that first thing. Okay, not much to set up. So I still have the oscilloscope connected to the output of the IF here. The oscilloscope's not going to be showing I don't know what it's going to show. I'm not intent on the wave shape. I just want to get the highest output I can get at 10.7. At least that'll get the IF centered on 10.7. Yeah, just knock this clip lead here. So this, where I'm putting this clip lead, oh no, where I'm putting the clip lead here is the front door of the IF. I found from experience I can afford to connect to this without disturbing the radio much. The 10.7 is coming from the FeelTech. Yes, I hear you there, Cat. That little signal generator sitting over here, that's a frequency counter signal generator combination magic box there. I had it up on my bench and discovered that it seems to be throwing signals out all over the place, which is very disappointing. A little further away it seems to be okay, I'm not sure. Keep an eye on that. This is the output from the signal generator. Right now it's set to 10 volts. I don't dare hook it up to there. If I were to clip it, I would clip it to the insulated wire here just for a bit of loose coupling. Still have a radio antenna connected here, but it won't matter much. I hope. He says. Okay, let me make sure the volume's down. Power on. We got a little something on the oscilloscope. Let me just tip this up a little bit here. Now, what now? I do not have the sweep generator connected to the radio, so there shouldn't be any signal coming from there. Ah, it's out of focus. Darn. Okay, let me fix the focus on that camera. Darn it. Okay, there we go. I would kind of expect just a straight line here, but maybe not. We won't worry about it. Now, I already have this signal generator going at 10.7 and it's in the room here. It could actually be coming out of the radio already. That's what you hear if you turn it way up. Just kind of a buzzy sound. That, I think, is probably the sweep generator, even though it's not connected. It's still putting a signal out in here. Okay, so I'm now going to... Oh, what did I do there? Very interesting. So what's happening here is I'm simply picking up the lead from the signal generator in my shop. In my hand, I'm picking it up on the insulation. If I touch the signal conductor, look at that. This is not even connected. It's just floating around my shop. Let me change the frequency here, way off. Huh, how do you like that? You can hear the beeping as I change the frequency, not tune it, but change it. 10.3, 4, 5, 6, 7, 8, 9, 10. Isn't that interesting? Now that's interesting in itself. Let's go back. 11, 10.9, 8, 7, 6, 5, 4, 3, 2, 1, 2, 3, 4, 5, 6, 7. 7 is right there. And if I bring this up close, I'll give you the longer shot here. God, there's an awful lot here to be concerned about. Just bringing it up close. So I can't afford to have this thing moving around while I'm doing this, and even if I'm moving around, it might be a problem. Plus, I put this up here, maybe it's way too much signal, but I can drop it. Let me clip it on the insulation here now. Yesterday when I was working in here, that actually bit through the insulation at one point, and shwang. Let me fix that. Let me just fix that. I know from experience I can touch this with my fingers. It just drives the radio nuts a little bit. Now if it bites through, there's a capacitor there anyway. Don't bite through. Can you hang on? Can't hang on. Oh boy, that's too heavy. Okay, wait a minute. We'll strain relief here. We'll try. This is getting complicated already. Here's a good spot here. I think, yeah, that'll strain relief. There we go. Okay, hopefully that's a stable thing. I'm watching the scope to see if my movements do anything. Now what I'm going to do with the signal generators, I'm going to manipulate the output voltage. It's at 10 volts, 9 volts, 8 volts, 7 volts, 6, 5, 4, 3, 2, 1. So 0, 1. Okay, 0. I think it must have been just way too high. That's 0.1 volts on this red wire, loosely coupled. 0.2, 0.1. I'm going to leave it right at 0.1 there. Now the object of the game is for me to tune the IF and make this line go up. Let's see how I do here. I'm going to do it kind of at random. No movement. Oh my god, I just turned the AM. Whoops, I made that mistake you're not supposed to make. I stuck my tool into the wrong thing. You know, that's a lifelong problem for men. Okay, here we go. I'm going to switch to the closer view here. My cat got tired and left. Okay, up to the top. Down here. Other slug. Up to the top. First transformer. They're all pretty darn close, aren't they? Really. And the last slug. Okay, that's one time through. Let's go again. Start again. Okay, let's make this a little more sensitive if I can. So I think you could have a narrow bandwidth in a radio like this and could receive FM mono fairly easily, fairly well. And that's kind of what happened with the radio, at least at one point. But you need the wider bandwidth to eat the whole signal. The bandwidth restriction could occur anywhere, I guess, even ahead of the IF in the tuner. So I think I now have the IF set. Let me change the frequency here and just see if it doesn't drop. 10.7 right now, 10.6, 5, 4, 3, 4, 5, whoops. What happened? What the heck happened there? Oh, I'm not changing the frequency, I'm changing the voltage. Okay, little mistake there. Okay, now we're ready to change the frequency. 10.7, 10.6, it went up. 10.5, went up. Oh my god, 10.4. What is that, tell ya? That's 5, 6, 7, 8, 9. So it looks like I've got it tuned to somewhere in this area. 10.5. How did I manage that? Very hard to understand. Okay, so what happens if now we're putting in 10.5. Wow, this is really not behaving the way I would expect. So I'm just tuning here, and it sure looks like, well, I guess maybe, no, I was going to say maybe, you know, when you get it, I don't know how to explain this. 10.5. These are all way out. Really wants to work at 10.5. Is there a possibility that that's kind of what's happened to this radio? That it's just not going to work at 10.7? Holy smokes. 10.5, 6, 7, 8, 9, 6, 8, 7, 6, 5, 4, 3. This didn't, what did I say? It didn't take 5 minutes, it took 10 minutes for the whole thing to blow up. Okay, it's blowing up. Okay, I'm going to reset things. We're going to look at the response curve shape and see what that can tell us about what is going on here. Okay, let's tune in the radio here to what's on the signal generator. Should be 1,000 hertz tone on here. Okay, so that's set to 100 megahertz. Tune the radio there. I'd say that's tuned there. Just turn that down a little. Right, I gotta change. You're right. That's no response curve. What's happening here? so sensitive here. Now I've stopped using a regular scope lead and switched to this clip lead. Earlier, fooling around in a little bit of testing, it suggested that the clip lead was actually just fine. But yikes. So what exactly is happening? I'm increasing and decreasing the signal level that the scope is seeing. What the heck? So I'm just going to move the clip lead in further here. Right off, of course. Wrong one. So I think with this resistor in the circuit, it's just creating the maybe from FM sweep to scope. This 15K resistor here is what I just skipped over. With it out of the circuit, I get a much better signal on the scope, stable signal. Don't think I damaged the, don't think I wrecked the situation here with the radio. Where's the hump? What's going on here? Don't have the sweep on, that's why. We're listening to a single frequency. Okay, sweep on. There we go. There we go. Much better. There we are. Very interesting. So, that is the IF shape that I've ended up with, just doing what I did. Chances are the center of that. Can we see the 10.7 coming through? Oh yes, we can. Okay, so what I'm gonna do is I'm gonna increase the RF signal. Yikes, not too much, just a little bit. It's changing the shape. Look at that, eh? That may still be too much. I have it loosely coupled to the antenna terminals. This is at 10.2, 10.3, 4, 5, 6, 7, 8, 9. Now, sorry about this, but high frequencies are on this side, lower frequencies are over on this side. It's backwards. Driving me a little nuts. I think there's a good chance if I reverse the power cord on the signal generator that would reverse, but I'm not going to do that because I can't reach it right now. What we're going to do instead, I'm going to lower the marker frequency down. Let's put it in where it's really affecting it. So this would be 10.6. Pretty well looks like 10.6 is right in the center. Okay, I'm going to reduce it over here. .9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I'm at 0 and there's still something there. This is a bit of a problem here. So we got too much coupling of this test signal. I'm going to try to reduce the coupling here. That's much better. What if I take the ground off? What if I leave the ground off and just hang this here? Too much. Okay, that's interesting. So what I want to do then is just leave this hanging here, I think. I've got to, it's a heavy wire hanging here. I've got to somehow strain relieve it. Oh my gosh, not now. Hello? Yes, this is Jim speaking. Okay, so that turned out to be a new customer. Got a 1930 something Rogers radio for me to work on somewhere down the road. So I've got about 4 radios waiting after this guy who's stuck here. He's stuck here. Okay, just a quick review. We have 10.6 marker frequency causing this thing here, dead center of the IF. The IF is on dead center on 10.6, but I was aiming for 10.7. Can't explain exactly why that didn't work out. Now, what should I do? I move this stuff, start trying to move this stuff, looking at that. So I'll set the, he says asking a question but not quite finishing it. There we go. Let me just flip the frequency up to 10.7 for a moment. There it is. 10.8, 7, 6. I really don't get why we didn't get this right. Okay, so now I'm gonna figure out for the first time which IF is the first and the second. Oh, it's really obvious. I'm going to start on this. I'm going to not follow the random instructions. I'm going to start with the second IF. And we're going to do this the way it would be normally done. Can't really move it much with that. That's the top slug, the bottom slug. That's doing a little more. So we're going to put it over there. Top slug again, over there. Now I'm going to go to the second transformer. Top slug, over there. Oh, for crying out, I'm going the wrong way. Once again, I'm really getting myself confused because I just want to automatically think higher frequencies are over here. Should I reverse that plug? Why can't I just reverse? No, I don't want to do that. You say reverse the leads going into the scope, but that would put the ground in the wrong spot. Just concentrate. Okay, going the other way. Back to the first transformer. Okay, over to the left. Second slug, over to the left. Now go to the second transformer. Join them over there. You go over there. Okay, let's flip to 10.7 here. Now, that's where we want the center of this to go. Oh my gosh. Okay. Okay, I'm in the second transformer here. Oh. Okay. You know, like these transformers that I'm tuning, they have capacitors either built right into them, or they could be discrete capacitors, but generally they're kind of built into them. These capacitors could be bad. If they're really bad, I'm reducing the coupling on the trying to reduce the coupling here. I just leave it hanging there. I don't like the idea of it hanging because it can swing. But there we are. That's pretty clearly that's peaked sharply on, yes, 10.7. The idea of this is just to allow for a test of the, basically the antenna capacitor. Let's just do this. Let me just do this. I'm gonna, does anything jump? What I'm doing is I'm fiddling with the antenna connection on the back of the radio here. Hopefully things just get weaker and stronger. Well, there we go. How do you like that? So it's not a big deal that it's changing size. The big deal is that it's shifting left and right. Like, you know, the center is here, and now the center is here. You know, the way I have this connected is buggering it up. Buggering it up. So I'm going to put the sweep generator on directly. So this was my technique for patting it down. Is a lousy technique. Another lesson learned. Follow the instructions. Okay, so we're going to hook up the signal generator directly. This will put a big signal into the radio. That's just the ground wire, or one wire. There's the other one. Make sure the output is as low as I can get it here. And it is. Jeepers, you know, how do you know that this thing isn't somehow, because how could I know? What am I saying? Finish a sentence, would you? How can you possibly know? You know, this is the pitfall that I fall into all the time. The test equipment is disturbing the stuff under test, and everything you do is false, because when you remove the test equipment, everything shifts, and that is probably what I'm really up against here. What they say is, from your sweep, have a 50 ohm resistor terminating the output of the sweep generator, and then you have a 150 ohm here and a 120 ohm there. And if we take a look, this is a 150 ohm resistor right here. That matches this one off the ground. And then we have, these all look like 150s. They all look the same. 3 150s in here. So I have a 150 here and a 150 here. Not a 50. Not a 50. Where is that? No, it looks like 150 everywhere. I'm going to just investigate for a minute that situation. Well, this is the manual for the signal simulator I'm using right now. These are the two outputs here. It should show a picture. This is the one that goes to your scope to cause the scope to sweep. Just 60 cycles on the end of these. Same 60 cycles in your outlet. Now here's the RF output. Ah, there's 3 clip leads. Well, I've only got 2 on mine. What's going on here? So you could guess this one with the black cover is one you would connect to the chassis, and then these 2 would go to the antenna. Oh, I don't have anything like that happening. Now I'm going to try to find the details in the manual on this. I already looked. I couldn't find them. I'm going to look again. See, it's going to be written somewhere, because I put in the resistors I put in based on something. I'm going to try to find that something in here. Well, here's a little bit written right here. The WR52 comes complete with 2 connecting cables, a direct unterminated cable for use with the composite stereo signal and audio signal outputs, that also carries the sweep signal that I'm using on the scope when you set the machine into RF sweep mode. Unterminated. And a terminated cable for RF output to a 75 or 300 ohm receiver antenna input. This radio has a 300 ohm input. So they've terminated it so you can do either. Cable holding brackets provided. So I think what's happened, just going back to the picture up here, is I've created these 2 connections. This one just goes back to the ground shield and basically to the cabinet, if you like, or the general ground inside this instrument. And if you were going to run on a 75 ohm system, I'm guessing this grounds to the chassis of the radio you're testing, and then either one of these, or maybe one of these in particular, will be the one you would use to provide the signal. On my arrangement, the lead I am using, both leads have resistors isolating them from the ground wire here. So I'm pretty sure this is what I've got. And this is nothing really. This is an easy thing to create. So I think I've got the right thing. The values of resistors I'm using, where did I get that from? So I don't know. yet. I don't know yet how I came up with that. But I could have got it as a standard thing and just gone and done it on this machine. But in any case, I don't think there's a terrible mistake being made with the output lead. For instance, having the instrument ground connected to one of the two antenna terminals. I don't think that's happening. This is quite a beast here. They have quite a detailed description of how to use it on a number of different radios as examples. But for the most part, I'm trying to follow the instructions that come with this particular receiver. Yeah. And I don't think I'm going to find anywhere. Yeah, before using it, read pages 4 and 5. I should go read those pages. I've read them many times. So I just don't think there's anywhere else in the manual where composite signal output. That's not what I'm interested in. I'm talking about the RF sweep output. Remove antenna from receiver, connect RF output cable. Set function control, set RF cable. So it doesn't really talk in detail how to hook up the antenna terminals. They're probably thinking if you don't know how to hook this instrument up to a radio, you shouldn't be using it. Maybe I qualify for that. All kinds of interesting ways of using it. I have not investigated these at all. Because of course, I'm doing my best to get the easy way out of this thing and out of fixing up this radio, and it hasn't proven out. Shortcuts become long cuts and all that. Okay, so lots and lots in this manual. Yeah. Nowhere is it going to give the details on the connector. I'm going to go right to the bottom. That's the end of the road. Yeah. Well, that didn't help 100%, but I feel a little more reassured. And the way I'm doing it should be okay. Oh, I think I'm about to learn a really tough lesson here. My thinking was changing the impedance of the connection to the antenna can't possibly disturb the tuning of the IF. It could disturb the tuning of the front end of the tuner, that's for sure. The radio is designed with an expectation you're going to hook up probably a 300 ohm antenna to those two screw posts, a folded dipole type antenna. I've never hooked up a folded dipole to that terminal. So from time to time, as I've been doing this alignment, I will do it, and then the next time I go to do it, I'll find it about 100 kilohertz off. This happened right off the bat. It could just be I'm hooking up this, this signal generator, then I'm hooking up this one, and the impedances are going up and down. This one does not have a properly terminated output on it, and I've just missed every time, just because of that. So son of a gun, why don't I hook up a proper 300 ohm folded dipole antenna? I don't really have a proper one. I have some that I built, simple stuff, and then just try to interact with that antenna. Yeah, there's going to be some stations picked up too, but maybe with some luck we can avoid that sort of interference type problem. And then at least I'll be doing this with a 300 ohm antenna. I guess another thing, I put a 300 ohm resistor right on it. Put a 300 ohm resistor and then close couple the output of the generator and forget about the antenna. Is a 300 ohm antenna the same as a 300 ohm resistor? Wow. It might be. Well, let's experiment and find out. Okay, I didn't have to stop the video for that. Here's a 300 ohm folded dipole antenna made out of 300 ohm flat wire. The ends are shorted out, and the lead is cut in here, and voila. Oh, I have to fix this up a little bit. We're going to put this on, and we're going to try to see if there's a difference. Yeah, we're going to try to see if there's a difference. Now I'll stop the video here. Okay, so we can guess that the antenna in the console, which I don't have here, is exactly the same as what I'm going to hook up here. Now I can still see these here. Let me turn up the brightness just a wee bit. They're still there. 10.8 already. 10.7 is sitting right in the center here. And that's getting into the radio from these leads just straight into the IF. I have this thing hooked up here. Okay, we're going to put on the antenna. Boy, oh boy, oh boy. You know, back in the early 1800s, people had discovered magnetism. Well, discovered much earlier, of course. Magnetism and its effect with electricity, and there was an awful lot of experimenting going on. Of course, nobody knowing what they're doing. There were a lot of people who thought there must be some way to use magnets and electricity to make a motor. And I may be wrong in saying this, but I believe there are people who spent their entire lives experimenting around the idea of making a motor. And some weird designs came up. A pool of mercury with a plate going in it and other things. Spend your lifetime trying to make what to us is a simple matter of a motor. And never did. Never did crack it. So should I be so surprised that it might take me a little while to crack this? Maybe not. I do kind of like watching documentaries about those people, early scientists, some of which were head and shoulders above everybody else. This would be some names I can't think of right now. In England, in the early mid-1800s. That didn't work. Now, has anybody been watching what's going on the scope? I didn't watch. That's one of the benefits you get, that I'd explained before. When I'm working in here, I must look at my hands and what I'm working on. I cannot look at the equipment. Whereas you can be gawking at everything. You can be looking at everything in my shop while I'm doing this. You have an advantage in that respect. Maybe what we all should do who do this work is have a camera running, and when you're done, watch the film of what you did. See all the things you missed that were happening. Oh, for crying out loud. Oh, patience running thin here. Yeah, it's the minor things that drive me nuts when they don't work out. Okay, it's on there. Now, just leaving it on my bench just where it is. You can see the output of the signal generator just laying right here. It's just open wires. This is the that weird antenna I was experimenting with before. You can see I used a transformer in here to convert this to 300 ohms. From 75, but who knows what's really in this. I think I mentioned, I've opened one of these once, years ago, and there was nothing in there. The wires just went straight through. There's nothing. Other ones I have seen inside, they do have little transformers. There was some attempt to do some impedance matching there, but I don't know what's in this. We don't know. Okay, but this is not an issue right now. A direct issue. Okay, what's happening there on the oscilloscope? Let's take a look. So I get a lot of noise now because the radio's busy receiving all kinds of stuff on that antenna. I can boost up my signal generator a little bit here. Oh, that does good. Oh, I like this. Okay, so let's go right up into this area here. I can see a little change in shape as I do this, so maybe just right in here. Now, can we identify the 10.7 marker? Oh my gosh, what was that? So the beeping you're hearing is me changing the frequency. It's 10.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Oh my gosh. 11 megahertz. What was going on back here? Whew. That's 10.3. What the heck do you make of that? The other thing I'm finding a little hard to understand is why this line climbs up and down as I inject this signal. I'm not going to worry about it, but oh yeah, no, I'm not going to. Yeah, I'm not going to worry about it right now. What else we were going to stick a resistor on there? You know, I'm going to stick the 300 ohm antenna and just go with that. I don't know how it could be a better choice. I don't know how there could be a better choice than doing it this way. In my shop, for me, on this day of September. And just 10.3 does that. Is it possible that the IF is actually at 10.3? So, well, if I reduce the voltage here, that's 0.1 volt, 0.2 volt, 3. There's nothing going on here. Okay, that's up by a factor of 10. Didn't change the thing. So what are we seeing here at this? This isn't from my signal generator. This thing. Wait a minute, it must be, because when I change the frequency, hang on, I'm going to set it to 1 volt. So there's 1 volt on the end of these. Oops. On the end of what? On the end of these clip leads, just hanging here. Nothing grounded, no nothing. Yeah, I can see a little bit of action on that. Okay. I turn off that signal generator I'm using, but when I turn it back on, it goes back to 0 settings. I have to reset it all. So I'm just moving the connector off. How about that? I can't seem to get rid of it. This is what was happening before with this guy. Has it got a spurious signal coming out of it? No, I can't believe it. So I've taken off the lead from the signal generator. Let me take off this cable, extension cable. Huh. Now, the signal generator, let me show it to you. There it is. It's just sitting here. Look what I'm doing with it. Turn that output off. Here, have a closer look at this. I'll do the same stuff, just flipping it around here and there. Oh boy. Now I got it over where I had it. I figured it was out of range. No, moving it around. You know the power cord? Oh, the power cord. The power cord is emitting. Oh my gosh. What craziness here. Just total craziness. What to do. That's when you hear me thump my fingers, that's because I just don't know what to do. Get rid of this. Like, I love this little thing because I can dial in exactly 10.7 or whatever. And what is it right now? It's at, you gotta be kidding me, it's at 10 kilohertz. 10 kilohertz. You gotta be kidding me. Okay, it's not kidding me. I'm gonna set it to 10 megahertz. That's 10 megahertz. 10.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, what the heck is that? Well, I'm going to switch it off. Oh, you've got to be kidding me. Switch it back on. What in heaven's name is going on here? This is just getting weirder all the time. Okay, let me bring it up here. Let's see what I'm doing. Seems to have no influence on it there. You can't read this screen. Maybe you can if I really get it up tight. You can start to read it. Okay, but once I get it up here, you can't see much else, can you? So right now we're at 0.01 megahertz. We're way off. 10 volt sine wave. I'm going to change that frequency so it says 10.7. There we go. That's 1 megahertz. 2, 3, 4, 3. 3. What happened to 3? 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's 10. 10.7. 0.1, 2, 3, 4, 5, 6, 7. What's happening at 10.3? Let's vary this a little bit. So 10.31, 10.32, 10.30. Okay, we're going to have to investigate this a little further. We're going to look at this on the SDR and just see if we can find a whole bunch of signals coming out of it, or what is going on here. Oh my god. Did I say it was 5 minutes before I go in the dumper? Boy, am I ever in the dumper here. Okay, I'm going to give you the full screen look at the SDR while I do this. So, right away, if you notice this area here, and you can see something going on here, that's the sweep from the RF sweep generator. I will reduce the sweep, and now it's producing pretty much a single frequency at 99.7 right in here. That's not really what we're interested in. Now, some of these other things you see, this stuff coming up here like this, just a sec, let me just get rid of this. There, the stuff you see kind of coming up here, don't know what to say about that, where that's coming from or what it means. This is interesting, this is quite interesting. What is it? I don't know. So the output of the little signal generator is at 10.3 megahertz. That's way off from here. We're at 100 megahertz. And this thing's putting out 10. Well, is it? I'm going to move this. I'm going to change the output frequency. Oh my gosh, look at that. Oh my gosh. So what this is telling me, by the way, that the FeelTech is sitting right on top of the antenna. Well, it's sitting on top of the antenna to the radio, but to the SDR antenna's a couple feet from it. Oh my gosh, it's just, this is sad. It's on sine wave. If I put on square wave, I'd kind of expect this kind of thing. And that's hardly changing frequency. That change you just saw was from 10.3 to 10.35. My gosh. Now I can jump down to 10 and take a look at it, but I have to make alterations to the SDR for it to receive that low right now. Well, okay, there's just spurious signals by the millions coming out of this thing. It renders it unusable. Again. Okay, once again I've determined the FeelTech cannot be used in my radio shop because of all the weirdness coming out of it. That's too bad. Now I bought that as a frequency counter anyway, but even if it's doing, hey, let me flip it to count. All that disappear? It does. What did I do? I flipped it too far here. Oh my god, there's all kinds of modes in this thing. There we are. So now I'm going to just switch it off. Look at that. Oh. Wow. Hey, modern equipment. You know, it's cheap. Cheap. Oh my god, I've been using that with my ham radio, with my shortwave radios, occasionally. Well, I turn it on, it's just going to spew nonsense right across the whole radio spectrum. Well, okay, so I'm going to stop and we're going to introduce my tried and true big military signal generator and put away the little plastic toy. That's really what it amounts to. I hate to say that, but how disappointing. So this is leaving. What a headache this is. And in its place, my good old military signal generator is going to take over as soon as my counter starts counting properly. In the meantime, the coffee cup awaits. Okay, so he's set to 10.7 or close enough anyway, and now we're going to take a look at the scope, and I'm going to try to get that to show up as a marker. I've got the output of the signal generator loosely coupled to the input of the IF, and I don't see anything there. So let's just raise the output here. There we go. Okay, believe it or not, 10.7's in the middle on this test. Believe it or not. Shall we believe it or shall we not? Good question. I'm going to relocate the scope. So that's, I just moved the scope input to the other side of this resistor, and you know, it looks really good now. So what I've been doing this morning is trying to make sure the IF is tuned to 10.7. Looks like it is. Now, can I prove that this is not working? Is there something I can do? Well, first of all, I can wave the radio antenna around a little bit. Does it shift? Is it going left or right? I wouldn't say so. So I'm changing the coupling between the signal generator and interesting. That doesn't react the way you would think. I just separated them and I got a more signal. Separated stuff on my bench here. Well, 10.7 sitting right there. I've got a little more juice in my... Ooh, well that's what happens if you overdrive it. So let me knock it back. Is there anything funny happening? Not really. Fantastic. I'm very much reassured. IF center tuned on 10.7. Can I get it higher? Can I get it bigger? It's another general male issue. Okay, here we go. That's how you can get it wider, like that. Isn't that a thing of beauty? I like that. I really like that. Now this is what I spent so much time getting, and I could never get it higher. So the suspicion is it won't go higher because the tuner is out of whack. And what's out of whack? We're going to take a guess. It's the capacitor that tunes the antenna. CA. Capacitor antenna. I'm not sure what CR is yet. So CA, all we're going to do is just turn it a little wee bit and see what happens. I have to figure out where it is. I'll show where it is. Here we are. CA. See if I can get it right. So looking at it like that, CA is bottom closest to me. That's this one. Okay, I'm going into CA. And I don't want to... You know, I doubt this is not tuned right. Uh-oh. CA is a screw. A screw. I need a screwdriver to do that. Okay, I'm putting a small aluminum screwdriver in. Didn't seem to upset the radio at all. That's me swinging the radio around itself on my turntable. It's swinging the antenna. Yeah, it's just antenna movement doing that. It kind of makes it clear that there's a real unnecessary peak over here. I'm not going to worry about that right now. what we're trying to find out is the CA way out. Very unlikely. There we are. I'm in. Okay, I'm in. Now I'm turning. Wait a minute. Hold it. I'm turning. Interestingly enough, it moves that display left and right. What's everybody think of that? Okay, the screw is very tight here. This is where it was. This is where I got it to. Where it was, where it can go. Can go further? Go further? I'm really cranking on it. Oh, I must be tightening down a capacitor. So it looks like there's even more here if I were to able to tighten it more. So that's a significant improvement there. We've lost track of the 10.7, so I'm going to give it a little boost here. I'm going to give it a big boost. Now, I believe I'm seeing, yeah, definitely the squiggles right here, almost in the middle. So there's two more adjustments. There's a CO, capacitor oscillator. I'm not interested in touching that one. And a CR. What is CR? C radio. It's the radio capacitor. So I'm going to find that on the schematic here and figure out what it is before I do anything with it. Okay, so here's the radio part of the schematic. This is the front end here. Here's the antenna. There's the antenna terminals. They just feed to a transformer through a tunable transformer, LA. I didn't see that in the list. Did not see that in the list. What about LA? What about LA? So you do LA and L oscillator. So it's L antenna and L oscillator. You do that at 92 megahertz. Whoops. But you're, oh right, you're supposed to do CA at 108. So it's not just a capacitor, it's a combination. So the fact that I boosted it up by turning CA out of the zone it likes is a mistake. That's a mistake. I've got to have the radio tuned to 108. We go to 108 and we can listen to the hiss and we can judge from there roughly what's happened. Oh, mistakes. Hey, mistakes. Should have studied this first before turning it. So we have L. We have LA and CA. Now CR is over here. So you can see what's going on here. There's a ganged tuner. You're tuning this main capacitor, and this main capacitor. Each one has a trimmer. CR, CA, and CO to do fine adjustments. And when we have LA, where's LO? Where is LO? On here. Should be down here, shouldn't it? Somewhere in here. LO. It's got to be, there it is, there, right there, right in front of my face. LO. What are you adjusting? So on this one they show an arrow suggesting it's got a movable core. L, you know, this might just mean local oscillator. LO. Oh, I don't see any coils to adjust here. Then this is the transformer I've been adjusting. Interesting, they show the core arrows in two different directions. Not really sure what they're trying to say with that. All these things can be hints, you know, that I could just be under, you know, failing to interpret properly. Oh, this is the fun of doing this stuff. This is what it's like, living on the edge. Okay, so we should really try to do this properly. I see by the clock the morning is over here. I think I'm going to stop at this point. I think I had enough breakthroughs here today, basically cleaning up what I'm trying to do so it'll work properly. That's really what I'm doing here. Okay, lots of lessons learned. Well, I said before, actually I said before quite a few times, there's always a cost to education. Doesn't matter what you do, there's a cost involved. Just learning by doing is not terribly efficient, especially if you're doing it on your own. But I personally find this the rock solid way to learn things. Once you get through all the schmozzle, wandering around in the forest is what I like to call it, you end up with a really good solid knowledge, as opposed to somebody just telling you do this, do that, which doesn't give you a solid knowledge at all, I think. Resilient would be the word. Okay, so tomorrow I'm going to come in here with great resilience and nail this radio. That's another way of saying I'm going to hammer it. Yeah, I have a hammer handy. Usually, at some point, I start to threaten the radios. Look, Mr. Radio, if you don't come around, this is going to be my final solution. Thanks a lot for watching. See you tomorrow.